Greetings, good morning. How are you guys doing today? We are here for our physics lesson. This is lesson number 2 in the first week. And today we are going to be looking at forces. We are going to be looking at forces, types of forces, results that come about when a force acts on different objects. Then I'll go through the objectives just now. So before I go on to talk about what we're mainly going to do in this second lesson, I would just like us to recall that in our first lesson we looked at force, but specifically we looked at Hooke's law. Yes, do you guys remember? We looked at Hooke's law. We looked at Hooke's law, and it was telling us basically about how the size or the elasticity of an object is directly proportional to the weight that is placed on that elastic object, right? So if the weight of the object, is doubled, then the elastic nature of that spring or whatever elastic material you're having will also double, right? And we gave an example of a spring where if you were to place 50 grams on it, right, there would be a certain extension, and then when you place 100 grams on it, the extension would double, right? And that is Hooke's law, which basically states that the elasticity of a spring is directly proportional to the load that is placed on it, right? So that was Hooke's law, and we drew different diagrams to show the spring constant, to show the direct proportionality, how the graph looks when you are adding the weights onto a spring or onto any other elastic object. So that's what we did in the previous lesson. So now we are now going to go into this second lesson on second lesson in physics. So I'm going to show you now the objectives that we have for today. So what are our objectives? By the end of this lesson, right, with our topic being force, by the end of this lesson, we should be able to recall and use the formula F is equals to ma. We should be able to recall and use the formula F is equal to ma. We should also be able to describe the way in which a force may change the shape or the motion of a body, right? The shape or the motion of a body. We should also be able to describe the types of forces, the type of forces that we have, that we experience in everyday life, right? So we'll just rush through this part because, like I said, in the first lesson, we have covered this concept in grade 9, we have covered this concept in grade 8. Okay, so you should also, by the end of this lesson, be able to carry out calculations using the formula F is equals to ma, this same formula, right? So before the end of this lesson, we should be able to have carried out a few lessons, a few calculations using the formula F is equals to ma, right? So you guys should just pause the video for a bit, write down the objectives of the lesson, just familiarize yourself, and then prepare yourself for this lesson. You can pause the video just for a minute, just to gather yourself. Okay? Cool. Right, welcome back, guys. It's your physics lesson with your teacher, Marshall A.C. Kandi-Addo. So today we are looking at force, right? And we should, by this stage of our academic careers, we are now in grade 10. We should now be able to define the term force. Right? So a force is basically, we define it as a push or a pull, right? Anything that causes a resultant an action that then causes a resultant reaction, right? That's a force. We will also in this lesson just look at I'll ask you guys to look at Newton's laws of motion. First law of motion, second law of motion. Right? But as we are carrying out these calculations, the good thing is that as we are doing this lesson, we will actually be explaining those laws of motion, and we actually observe, right, these laws, Newton's laws of motion, just like the simplest one. For every action, there is an equal and opposite reaction. for every action there is an opposite and equal and opposite reaction. That's actually Newton's first law of motion, right? So you will find that this will actually apply as we go through the lesson, right? So now let us look at the first thing, the formula for calculating force, right? So we were saying force is equal to mass. The F is for force, the M is for mass, right? Mass multiplied by, this is the M multiplied by the A, because when we say F is equal to MA, MA is the same as saying M multiplied by A, right? So M multiplied by A, that's mass multiplied by acceleration. Mass multiplied by acceleration. That's the formula for force, right? So that's the formula that we will use. If we want to find force and we are given the mass of an object and we are given the acceleration of that object, then we are able to calculate the force. Then we are able to calculate the force. The beautiful thing about it as well, right? Just take this in. Force, the F stands for force, right? The F stands for force. Force equal to mass times acceleration, right? So the beautiful thing is that we can actually substitute these units, right? Let's say we have a situation where we're given mass and force, right? We are given the mass and the force, but what we need to find is the acceleration, right? So which means that we would have to say we are given our base formula that we are comfortable with is this one. F is equal to ma. But we have cases where we are given F and where we are given M and we are looking for A, right? And we are looking for A. So we should be able to make A the subject of the formula, which means that we would want A to remain on this side alone whilst M goes this side. So what do? We would then divide both sides because we want to eliminate M from this side. We'll divide both sides by M. This would then therefore imply that acceleration is equal to force over mass. Force over mass. I didn't want this one to be looking like an E, just in case you end up getting confused. So this is what we end up having. So we can substitute any of these units to find acceleration, to find mass, or to find force, given which known quantities are we having initially. Okay, so look at that. Just pace yourself. Just pace yourself. As we're having these physics lessons, I need you guys just to pace yourselves, to look at the whatever idea or concept that I would have put forward. Just rewind it a bit. Read about it. Open your living physics. Open any other physics textbook you're having. Just read about it. And then when you are comfortable with it, then you can move on. Right. Now, let's look right now. I would like us to look at the effects of forces, right? Describe the ways in which a force may change the motion of an object. These are the effects. What effects do forces have? And we know that a force can change the shape of an object, right? As I'm saying these things, you should just try and build an image, try to think how would a force change the shape of an object. If you were holding a container, right? If you were holding a container, I'm looking in the classroom to see if there is a container, right? Or any other object, right? So let's say this is the object. This is just a basic exercise book. But because now you see its shape is like this, right? This is its shape, right? But then when I apply a force to it, because when I'm actually folding it, that's applying a force onto it. And because now I'm applying a force, the shape of the book is now changed, right? So initially it's like this, right? But then when I apply a force onto it, the shape of the book changes. And that is the same thing that we observe with different objects. When a force is applied, the shape of the object can change. The speed at which the object is moving may also change, right? The speed at which an object is moving may also change. It changes, either the speed might increase, or if the object is moving very fast, imagine a car that is moving very fast and then you apply brakes onto it and then the car comes to a complete halt. Right? So now, because of the force of friction that has been applied by the braking system, right, the speed and the motion of the object has actually changed. You can also change, what else can we change using this force? Okay, give yourself a bit of time to try and think of other ways in which forces can change the motion of an object. Okay, so you can pause the video. We'll be pausing the video several times just to give ourselves enough time just to also imagine and think how forces can be used to change the shape or the motion of an object. So you may pause the video again, right? Okay, so now I think we have now thought of different ways in which forces affect the direction of an object. Right? The direction of an object, you can have a ball that is moving, if a ball is rolling towards me, right? A ball is rolling towards me, but then if I just deflect it, right? If I apply a force, right, it just hits, like it's just a snooker ball that is rolling towards me, it just hits my hand, it deflects and it goes in a different direction. That is a force, an effect of a force, right? So now, let us move on. Two types of forces, because I'm sure you're familiar with everyday effects of forces. And then now let's look at the types of forces that we know. Right. So what are the types of forces that you can recall from your grade 8 and grade 9 work? Try to remember. What are the types of forces that you remember discussing or being taught about or just observing in life in general? Which forces do you guys remember encountering in grade 8? In grade 9, when you were just going to the shops, when you were walking around, which forces? Okay, so try to write down at least 4 forces. Try to write down at least 4 forces that you think you remember that you covered from grade 8 or from grade 9 or that you have just observed in your life. Write down 4 forces. I'll give you 4, I'll just give you 3 minutes. I'll just give you 3 minutes, right? I'll give you 3 minutes. You can pause the video for 3 minutes and you can write down 4 forces, or even 5, or even more if you know. Okay, so you can pause the video and you can do that. Right. So now you have written down the forces that you know. Okay, if you have already finished, you can pause the video. You can just make sure you don't have to rush yourself. You can pause the video again and you can just finish writing the forces that you know. Right, so the first force that I will just highlight is the one that is keeping me grounded onto this floor, right? If that force was not there, I'll probably be floating and flying all over the place. I would just be flying and then I would need to find a way to come back onto the ground. Which force is that? Which force keeps me grounded and which keeps us from floating away? Which keeps everything, the desks in this room, which keeps them from flying away? What is that force? Yes, that is the force of gravity. The force of gravity. So that's one type of a force, the force of gravity, gravitational force. It pulls, it's a force that pulls everything towards the center of the earth, right? It pulls us towards the center of the earth, therefore we remain grounded. Which other type of force do you guys remember, right? I think when we talked about how when you are able to move, and because you are able to move and you are able to walk, and you are even able to walk backwards, what force allows us to be able to move? And not sleep. Just imagine if that force wasn't there, we'll just try to move and we'll sleep and we'll fall onto the ground. That is the force known as friction, right? We have the force of friction. And the force of friction is what allows us to actually move, to be able to walk forward, right? Otherwise, we'll just sleep. Or if we were to push an object, then it will move continuously. Forever, it will move from here, past Oshakati, past Oshikuku, all the way to Rakana, all the way to Angola. It will keep on moving, right? So we have gravitational force, we have frictional force. Then we also talked about yeah, I think in grade 9, we talked about how we have all these devices that we're using. They are powered by electricity. They are powered by electricity. So we have something that is known as electrical force, right? Electrical force. That is a common one. This is why when the power goes out, people go, the power is gone, right? So those are types of forces. Those are types of forces, and I'm sure you are aware of them. Then you guys will go on and you look for several other types of forces that we experience on this planet, right? So now, what I want us to do, right? I want us to proceed now to carry out some calculations. I want us to carry out some calculations, just a few, right? In the document that you have, the Word document attached onto this video, right? This video came along with the Word document, and that Word document is having exercises, right? An exercise with these questions. So these are the questions. I will just help you with a couple of them, right? I'll just help you with maybe 2 of them or maybe 3 of them. Let me just do 2 because I already put the answer for the first one for you. So yeah, let's do the first one and the second one. And possibly, if there's still time, I will do a third one with you guys. Okay, so you may again pause the video, just allow yourself to take a breath, pause the video for about 2 minutes. Thank you. Okay, welcome back. So now we want to carry out calculations using the formula force is equals to F is equals to ma. We will change it, right, depending on the type of question that we have been asked. Right. So our first question that we have is saying determine the size of force. Determine. I don't know if you're minding what you're doing. Determine the size of force needed to give a mass of 8 kilograms and acceleration of 2 meters per second squared. Right, so these are word questions, and with these word questions, it is important that you're able to identify the information that you're given. So remember, your formula is this one: F is equals to ma. So what you should be able to do whenever you're given a word question is to identify: am I given force? Am I given mass? Am I given acceleration? Or what is being asked for? So you are being asked for to say determine the size of the force. Therefore, the force is not there. That is a question mark. That is a question mark. So, what is the mass? The mass is given. The mass is 8 kgs. What is the acceleration of this object, which is a mass of 8 kgs? The acceleration is 2 meters per second squared. So, using this information, we are able now to take this information and fit it into our formula. We are able to take this information, the mass, the acceleration, and because the mass is given, it means it's this one. The acceleration is given, which means it is this one. Which means we can substitute these units with these numbers. Are you still there, guys? Are you still there? Right, so just rewind and look again at what I've just said. We are able to take these units and substitute them for these letters, right? That will allow us to calculate the force. Right, so let me do that. So force is equal to what? Force is equal to mass. The mass is 8 kgs multiplied by acceleration, which is 2 meters per second squared. Right. What is our answer? Right. So therefore, our force will be 8 times 2, that is equal to 16. Right, 16 what? 16, I'll write the long answer for it, right, the long formula, right, the long formula which is kg meters per second squared. Right, kilogram meters per second squared, because you have multiplied kgs and you have multiplied them with this. Right, but then that is just the same as writing 16 newtons. That is the same as writing 16 newtons, right? 16 newtons. Okay? So that is your answer for this calculation. Right, let's do a second one. This one I hope you've done it, or you'll be able to do it, or you've done it by yourself. I'll let me do it for you as well. Right. So now I'm going to erase this one. I'm going to erase this one. So it's to create space. So as you're doing these calculations, right, there's the work that I gave you. Make sure that you look for as many questions as you can. Because when you do more and more calculations, you become adept at it. So let me just do a second calculation and we'll conclude this lesson. Right, so now the second question reads, what mass will have an acceleration of 6 meters per second squared using a force of 24 newtons? Right, so again, now we can tell that the F, have we been given force? Force is given as 24 newtons. Do we have equals to ma mass? What is the mass? What mass? So you can tell from the question that we are looking for mass, therefore the mass is unknown. An acceleration of 6 meters per second squared. 6 meters per second squared. 6 meters per second squared. How much is that? Right, that's acceleration. So now we have to recall that F is equals to ma, therefore m by substitution we divide both sides by a, and a. I just did it a bit fast, but you can slow down. F is equals to ma. So for us to find m, we have to cancel the a that is this side. And for us to be able to cancel the a that is this side, we have to divide both sides by a. So I divide both sides by a, and then these two, they cancel out. I hope you are friendly with the mathematics and you are friendly with basic mathematical concepts. So now m is equal to, Fa is equal to m. So m is equal to F over a. F is the force, a is the acceleration. Then we substitute the figures for the letters. Right, so this is the same as saying mass is equals to, what is the force? The force is, what is the force? I'm sure you can see, that is the force, that is the force. So mass is equals to this force divided by this acceleration. Okay, so that is mass is equals to force, I'm supposed to write the actual number now, which is 24 newtons divided by 6 meters per second squared. Okay, 6 meters per second squared. So when you divide them, you must remember the SI units. You know the SI unit for mass, right? You know the SI unit for mass. So when you divide 24 divided by 6, right? A bit of mental math there. 24 divided by 6 is equal to 4. So the mass of this object is 4 kgs. Right, it's 4 kgs. That will be your mass. Right, you have 3 more questions that you guys can calculate from this exercise. I will need you guys to calculate and complete those answers and then send them to me. Okay, so now I'm sure we are able to recall and use the formula that F is equals to ma. We're able to describe the way in which forces affect the shape, the motion of an object. We are also able to state and describe types of forces, to say, to ask what is an electrical force, what is the gravitational force. You are able to describe what the gravitational force is, right? So you guys have been the best. You've always been the best. You are the best. Thank you for watching this lesson. Thank you for rewinding it several times and watching it again and again so that you understand these concepts. I know you can understand the concepts because you guys are bright and you guys can reach for the stars. You can do whatever it is you guys want. Stay blessed. This is your physical science, your physics teacher, Marshall A.C. Kandiaga. Thank you.